Hello everyone, welcome to Sin Theta Math. I made this channel to help students with their Algebra 2, Precalculus, and Calculus topics. I will be going in depth on the units that we learn, and will be taking requests on specific types of problems. To start off this channel, I'd like to present a challenge problem. The problem starts off with the statement, the function f of x equals 2 sine of 3x has a maximum at the point a, b. Find the value of 2 sine of a plus b. Now we see that a, b is this big red dot right here, and it's the first maximum of the function. Now, a is our x value and b is our y value, so we have to find each of those and then plug them into the equation on the right. Now let's start off with finding b, because it's a bit easier to find the y value. You can just look at the graph and see that it's 2, but if you were dealing with this equation on a test and you didn't have a graph, here's how you would find it. We have to find the amplitude of the equation and then add it to whatever vertical translation we have. But in this specific function, we don't have a vertical translation. If we did have a vertical translation, it would look like something 2 sine of 3x and then plus some number or minus some number like 3 or 4. But in this case, we don't have any. So we can just find the amplitude, take that, and we have our maximum. So our amplitude, we write it as a, is equal to the equivalent to the absolute value of this number being multiplied to the sine function, which is just 2. And now that's equal to 2. Alright, now that we have and then this is just our maximum. So now that we have it, we can just say that b is equal to 2, and I will write that right there. Great, now that we have our b value, we can move on to finding our a value, which is a bit more difficult because we don't really have anything on the x-axis to tell us what is a. So, we have to work out something in the equation. Now, what we need is the period of the function divided by 4. Now, why do we have to find the period of the function and then divide it by 4? That's kind of weird, right? Well, let's think about it. Let's say we start from here and we have a 0 of the function. Then we go right here and we have a maximum of the function. Then we go 0 and then we go minimum. And these points are evenly spaced out. And then if we go to this next part, we have a 0, a maximum, a minimum, or a 0, and then a minimum. And just keeps repeating over and over again. 0, maximum, 0, minimum, 0, maximum, 0, minimum. So we have to divide by 4 because each of these are just the period of sine x, or in this case, our function. Now to find the period, which is called p, we have to take this number that's being multiplied to the x right here, and then take 2 pi over that number. So 2 pi over, and it also has to be the absolute value of a number, I forgot. But right here, the absolute value doesn't really matter because it's already positive. We can just take this as 2 pi over 3. Now that we have our period, we have to divide it by 4. And the way to do that is we can just do 2 pi over 3 and then multiply it by 1 over 4, which is the same thing as dividing it by 4. And in this form, it makes it easier for dividing fractions because we can just multiply across. We had 2 pi on the top, and then 3 times 4 is 12. And we can simplify this down to pi over 6, which is great. Now we have these critical points that I was just marking down. So right here we have x equals 0, right here we have x equals pi over 6, and right here we have 2 pi over 6, and then 3 pi over 6, and on and on and on. Right here we have 4 pi over 6. But we don't really need to move on after that. We already have our x value of the maximum right here, pi over 6, you see? So now that we have our a value, which is pi over 6, we can just go back here and plug it in. So our final answer to this would be 2 sine of a plus b, which is equal to 2 sine, well look, a is just pi over 6, and then b is just 2. Now how do we find sine of pi over 6? Well, to make this easier, let's convert pi over 6 to degrees. The way we do that is we take our radian value, which is in the form of pi over something, or pi multiplied by something, in this case pi over 6, and we multiply it by this conversion factor, 180 over pi. Now as you can see, the pi's will cancel out because they're on the bottom and the top, and we're just left with 180 divided by 6, which should be pretty simple to solve. It's just 30. Now we have our value of 30 degrees. And you might already know what sine of 30 degrees is. You can draw out the special right triangle Right here we have 30 degrees, right here we have 60 degrees, 90 degrees. This bottom side will be square root of 3, this opposite side will be 1, and then the hypotenuse will be 2. Now, we can take sine of 30 degrees by taking the opposite side, and then dividing it by the hypotenuse. So sine of pi over 6, which is equal to sine of 30 degrees, is just equal to 1 over 2, opposite over hypotenuse. Now we can come back here and plug that into our equation. So this will be equal to 2 times sine of 30 degrees plus 2, but then sine of 30 degrees is just 1/2 plus 2. And then we can see that this 2 and this 1/2 just cancel out to be 1, and then 1 plus 2 is 3. And that's the solution to our equation. I hope you guys enjoyed this video. I know this was a bit of a long and awkward video, but hopefully over time the quality will increase, and over time we'll be able to do more problems like these quicker. I just wanted to be as in-depth as possible so you guys understood every step of solving this equation, because I know it's a bit of a challenging one. Anyways, if you guys have any requests to go over certain topics, please leave them in the comments, and I will see you guys later. Good night.